This is the friendly review for Chapter 2. We're still in Chapter 2. And for number 1, Part A, we're analyzing this graph. It wants to know, when x equals 2, what the y value equals. Q is 2. When the x value is 2, notice my y value will be 4. And that's all I put over here for my answer, is 4. There's another question, though, when x equals 4. When x equals 1, 2, 3, 4, what's the y value equal? 3. So there's 2 spots for that. For Part B, when x equals 6, when x equals 6, when x equals 1, 2, 3, 4, 5, 6, what does the y value equal? And that is 0. When x equals 8, 6, 7, 8, what's the y value? Negative 2. Pretty smooth. Is f of 1 positive or negative? So what they're asking is, when x equals 1, is that y value up there positive or negative? And in this case, it's above the x-axis, so that means it is positive. Is f of negative 1, when x is negative 1, is the value positive or negative? So there's negative 1. When I go above, that's going to be a positive number again as well. Part E, for what values of x is y equal to 0? So basically, if it goes through the x-axis. Or you can look at the coordinates and notice y equals 0 there, y equals 0 here, and y equals 0 at this spot. So at negative 3, 6, and 10. Part F, for what values of x, and f of x means y, I should have specified that for Part E. For what values of x is y greater than 0? Is y positive? Is y above the x-axis? Above the x-axis. That's all the items it's asking us. When is y above the x-axis? So y is above the x-axis in this region here, and then y is above the x-axis in this region. So it's going to be an interval notation starting at negative 3, ending at 6. So from negative 3 to 6, union, and it picks up again at 10. It goes above the x-axis at x value 10, and then ends at x value 11. Now I state this time and time again, that's a closed bracket on that 11, because 11 is at 1, but 10 is at 0. And notice, it would have been a closed bracket on each of these parentheses if I switched that from greater than to greater than or equal to. But it's not, so it's an open parenthesis on each of these, because it's an open circle. Except on the 11, notice, 1 is greater than 0. So because that's greater than 0, it gets a closed bracket on that interval. Where's the domain of f? That's going to be my smallest x value to my largest x value. Closed bracket, negative 6 to positive 11. It's a closed bracket because that is a closed circle. What is the range? That's going to be my smallest y value. My smallest y value is negative 3 to my highest y value of positive 4. Again, a bracket from negative 3 all the way up to positive 4. Part I, where are the x-intercepts? Where is it across the x-axis? At negative 3, 6, and 10. Part J, what is the y-intercept? Where does it cross the y-axis? And that's at y equals 3. Part K, how often does the line y equals 4? Y equals 4 intersect the graph. So y equals 4 is a hoi. So that's a horizontal line through y equals 4. So y equals 4 is up here, and that's going to be a horizontal line that goes through y equals 4. Let's see what we can do here. And notice, that horizontal line touches the curve at one spot. So that's one time it intersects the graph. And that's actually called a point of tangency. A point of tangency. How often does the line x equals 5, the vertical line, that's a vux, the vertical line at x equals 5 intersect the graph? So there's the 5, and it's going to be a vertical line going through there, and you can see this intersects the graph at exactly one point. Part M, for what values of x does y equal 3? So I'm looking for y value of 3, y value of 3 there, y value of 3 there. Pretty easy, that's 0 and 4. Part N, the last part to this question, for what values of x does y equal 4? So y equals 4 there, and the x value is 2. These can get to be more challenging. Number 2, more graphical analysis. When x equals 2, what does y equal? When x equals 2, y equals negative 2. And I don't think there's any other value for that one. So when x equals 5, what does y equal? Y equals 3. When x equals 0, y equals 0. When x equals negative 2, that's what f of negative 2 means. When x equals negative 2, y equals 1. Part C, f of 1, positive or negative. So when x equals 1, is that spot on the graph a positive number or a negative number? The y value is negative. When x equals negative 3, and is that y value on the graph positive or negative? Notice it's above the x-axis, so it is going to be positive. Part E, for what values of x is y equal to 0? So y equal to 0. So y equals 0 here, y equals 0 here, and y equals 0 here. I guess they're trying to re-emphasize what the x-intercepts are, and that's at y equals 0. So it's going to be 0, 4, and 6. Part F, for what values of x is y below the x-axis? For what values of x is y negative? For what values of x is y less than 0? So y is less than 0 in this portion of the graph, this portion that's below the x-axis. So it starts at 0 and ends at 4. So it's going to be from 0 to 4. But it's parentheses for this because it doesn't have a little line underneath. If it had the line underneath, then that would be a bracket or the interval notation 0 to 4. What is the range? Part G. What is the domain? What is the domain of f? The domain is from the smallest x value, which is negative 4, to the highest x value, which is 6. Negative 4 to 6. I'm getting off the screen, so I'm going to write my answers over here now. What is the range of f? The range is the smallest y value to the highest y value, which in this case would be 3. So from negative 2 to 3. The range is bracket negative 2 to to 3, close bracket. Where are the x-intercepts? That's where it goes to the x-axis, 0, 4, 6. We already had those answers for another question, 0, 4, and 6. Where's the y-intercept? That's where it crosses the y-axis. That's just going to be 0. This one's a little tricky. How often does the line y equals 2 intersect the graph? Remember, this will be a horizontal line through y equals 2. So I got the y equals 2, and that's that spot there. Now I'm going to draw a horizontal line through it. How often does that horizontal line hit the curve? And this is the tricky spot. It does hit it at that spot. It hits it here, and it hits it here. So that is 3 places. I guess you could see that. 0, 4, 6. Can't see that. From negative 2 to 3. Sorry for my poor penmanship. Part L. How often does the line x equal 1 intersect the graph? And that's a vux, so it's a vertical line through x equals 1. So I go to x equals 1, and I draw my vertical line. And that's going to intersect the curve in one place. One place. For what value of x does y equal 1? For what value of x does y equal 1? For what value of x does y equal 1? And this is a tricky question, because y equals 1 here, and they give me the coordinate. But notice, if I were to draw the line y equals 1 across, I get 3 spots where y equals 1. I get a spot here and a spot here. Y equals 1 here, y equals 1 there. So y equals 1 here, and that's at negative 2. Y equals 1 here, and that's at maybe 4.1. Y equals 1 here, and that's at maybe 5.8. So you have to be a little ingenious to figure out what those coordinates are. I know they don't have to be exact. You're just doing an estimate, approximation. So y equals 1 at x equals negative 2, 4.1-ish, and 5.8-ish. Approximate. For what values of x does y equal 2? So at y equals 2, that's going to be this horizontal line, which I had already drawn and erased. Y equals 2. Again, I have 3 spots. There's one at negative 4. There's a spot. X value negative 4. Now I need to know this x value. Notice it's just a little bit past what I put 4.1. So we'll put it like 4.2-ish. And then this one here, we said it was at 5.8. So we'll say this one is at maybe 5.3-ish. A little tricky. The difference quotient. So, in order to evaluate this using the difference quotient, I use a big division bar all over h with a minus sign on top. I place this f of x behind, so 3x squared minus 5x. I bracket that up in parentheses. Now I make a template of this, so it's going to be 3 parentheses squared minus 5 parentheses. And in those parentheses, I put the x plus h. Big division bar all over h. Now I have some algebra to do, so I have to square the x plus h. X plus h to quantity squared is x squared plus 2hx plus h squared. And I have to put that 3 in front. A little bit of petty algebra, negative 5x minus 5h. Distribute the negative, negative 3x squared. Distribute the negative, plus 5x. I still have more algebra to do. I have to distribute this 3. That's going to give me 3x squared plus 6hx plus 3h squared minus 5x minus 5h minus 3x squared plus 5x all over h. Working from the back end, I'll notice that the 5x simplifies with the negative 5x. I should also notice that the negative 3x squared will simplify with the positive 3x squared up front. Another division bar, 6hx plus 3h squared minus 5h all over h. Muchos hot cheese moment. So I can simplify this a little bit more by factoring out an h. And the h is going to be on the bottom. Now preemptively you can see that the h's will simplify. And inside my parentheses I'm going to be left with the 6x plus 3h minus 5. Notice h times 6x is 6hx. Notice h times 3h is 3h squared. Notice h times negative 5 is negative 5h. These simplify, and that leaves me with the final answer of 6x plus 3h minus 5. And that is the difference quotient. Graphing number 4, this is y equals mx plus b format. So my plus b is a plus 0. So my mx plus b, my b is 0, so I begin at 0. My slope is 2 over 1. So from that beginning spot, I'm going to go rise up 2 and go right 1. And we continue doing that up 2 over 1. I run out of room, so I do it in the other direction. And then I connect the dots with a straight line. Answer the questions. Is this a function? Yes, it passes the vertical line test. The x-intercept is 0, the y-intercept is 0, and the domain goes forever to the left and forever to the right. So that's going to be negative infinity to positive infinity. Number 5. I begin at 4, and my slope is down 2 over 1. So I begin at y-axis positive 4, and my slope is down 2 over 1, down to right 1, down to right 1, down to right 1, down to right 1. I'll connect the dots. Is that a function? Yes, it passes the vertical line test. The x-intercept this time is 2, the y-intercept is 4, or you can just look at that. The domain is going to be from negative infinity to positive infinity. Number 6. I begin at y-axis positive 2, and then my slope is rise 1, run 2, up 1, over 2, up 1, over 2. And continue the pattern in the other direction. Connect the points. Is that a function? The answer is yes. It passes the vertical line test. The x-intercept is at -4. The y-intercept is at +2. The domain, it goes forever to the left and forever to the right, is from -infinity to +infinity. Number 7, x equals 2. I will call this a Vux problem. That means VUX, x equals 2. This is a vertical line at x value 2. So I go to x value 2 and place a dot, and then I strike a vertical line through that. Vertical line goes straight up and down. The U from Vux will mean that the slope of a vertical line is undefined. Is a vertical line a function? The answer is no. A vertical line fails the vertical line test. Unless you are a mathematician in UF, they do something weird with this, but we're not there. The x-intercept is 2. The y-intercept is none. The domain, be careful, is not interval notation, it's set builder notation, and it's just going to be one value, 2. Those are braces. Hoi, y equals -2. This is a hoi. Y equals -2. That's a horizontal line through y equals -2. So I go to y equals -2 and place a dot, and then I graph a horizontal line through y equals -2. Is that a function? Yes. A horizontal line passes the vertical line test. It only hits it once. So yes, that's a function. The x-intercept, it has none. It does not hit the x-axis. The y-intercept is -2. And the domain is all real numbers from -infinity to +infinity. A parabola. And this parabola has a vertex located at the opposite of -2, that's +2, and the same as -4, down 4. I go right 2, down 4 from the vertex. Right 2, down 4 from the vertex. And that's from the origin, and that's my vertex. Now I'm going to implement this little trick called 1, 3, 5 for an x squared. So from that vertex, I go up 1 over 1. I go up 1, 2, 3 over 1, and then I go up 1, 2, 3, 4, 5 over 1. I go back, up 1, left 1, up 3, left 1, up 5, left 1, and then I connect the dots. Is that a function? The answer is yes. The x-intercept, I have 2, at 0 and 4. The y-intercept is at 0, and the domain of an x squared is all real numbers, -infinity to +infinity. Number 10, a little bit different, a little bit scarier. Notice it's an x squared, quadratic or parabola, but this time I have a leading coefficient of -4 out in front. My vertex is still going to be at -1, +4, -1, +4. So from the origin, I'm going to go left 1 and up 1, 2, 3, 4 and put my dot. But now when I do 1, 3, 5, notice I have something out in front of the parentheses, and what's out front is a -4. So I have to multiply my 1, 3, 5 process by -4. So that means instead of going down 1 over 1, I now have to go down 4 over 1. Down 1, 2, 3, 4 over 1. And then down 12, but that takes me way off the graph. So I go down 4 over 1 again, and my graph is going to be this really narrow, upside-down parabola. It's upside down because of the negativo. Is that a function? The answer is yes. The x-intercept is at -2 and 0, and the y-intercept is at 0. Radical function has a vertex, or a starting point, is what I prefer to call it, at -1, -1, opposite chain. So I go left 1, down 1. This one I implement 1, 3, 5, 1. But it's not squared, it's square root, so it's going to go elongate. It's going to elongate. So I go up 1 over 1, then I go up 1 over 1, 2, 3, versus up 3 over 1. And then I'm going to graph that. And is that a function? The answer is yes. It passes the vertical line test. The x-intercept is at 0, the y-intercept is 0, and for some reason I forgot to ask you about the domain and range for this one. Number 12. A cube root radical. Cube root is going to look like a super S. But I need to know where that turning point is. And that turning point is located at 1, 1, 1, 1. So I go right 1, up 1 from the origin to get my turning point. And then, if it's a cube root, remember it goes up 1 over 1, down 1 over 1. And then it's going to be slanting in a super S style. Like that. Is the super S a function? The answer is yes. The x-intercept is 0, the y-intercept is 0. The domain is all real numbers from -infinity to +infinity. Absolute value function. The vertex is going to be located at 2, -3. So I go right 2, down 1, 2, 3. And notice there's technically a 1 over 1 out front, so I'm going to go up 1 over 1, 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 connect the dots for my v. Is the absolute value function a function? And yes, it is. 2 x-intercepts at -1 and 5. The y-intercept at -1, and the domain is going to be all reals.